December 17, 1944. Bastogne, Belgium. Through the periscope of his Panther tank, Oberfeldwebel Ernst Bärkmann watched another American Sherman burn on the frozen road ahead, its crew scrambling through the hatch as smoke poured from the engine compartment. His gunner had punched through the Sherman's frontal armor at 800 meters with a single 75mm round, a textbook kill that should have brought satisfaction. Instead, Bärkmann felt something closer to dread. This was the fourth Sherman his crew had destroyed that morning. By his count, they had knocked out 11 American tanks since the offensive began 3 days earlier. Yet each time his Panther crested a ridge or rounded a corner, more Shermans appeared. Where the previous 4 had burned, 6 more now advanced through the smoke, their commanders seemingly unconcerned that they were driving past the wreckage of their predecessors. Bärkmann had fought across Russia, through France, and now Belgium. He understood armor warfare's mathematics. A Panzer unit that lost 4 tanks in a morning had suffered catastrophic losses requiring weeks of replacement and reorganization. The Americans he faced seemed to operate under different mathematics entirely. They lost tanks the way infantrymen expended rifle ammunition, as if mechanical complexity and industrial effort meant nothing, as if destroyed Shermans were merely consumed resources rather than irreplaceable weapons. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The central question that haunted Bärkmann and thousands of German tankers across every front was becoming impossible to ignore. How could the Americans, who had entered the war 3 years after Germany, who fought across 2 oceans simultaneously, who supplied Britain and Russia while building their own massive military, possibly produce enough tanks to replace losses that would have crippled any German formation? The mathematics seemed impossible. The industrial capacity required defied comprehension, yet the evidence rolled forward on 30-inch wide tracks, arriving in numbers that transformed tactical victories into strategic irrelevance. What Bärkmann couldn't know as he ordered his driver to reverse into cover was that his 4 morning kills represented approximately 6 hours of American tank production. While his crew had fought desperately to survive the Battle of the Bulge, American factories had already replaced those 4 Shermans and built 6 more. The industrial system that had produced the tanks he'd destroyed that morning would manufacture 48,234 Sherman tanks between 1942 and 1945, an average of 33 tanks per day, every day, for 4 years straight. This wasn't mere production. It was industrial capacity at a scale that rendered traditional military calculations obsolete. German tankers had trained in a world where tanks were precious resources, carefully husbanded and strategically deployed. They faced an enemy that treated tanks as expendable tools, manufactured in quantities that transformed quality disadvantages into quantitative inevitability. The psychological impact of this realization, the slow comprehension that they fought not just an army but an industrial system beyond their frame of reference, would prove as devastating as any battlefield defeat. The story of German tankers confronting American production capacity reveals how modern warfare's nature had fundamentally changed, how industrial might could overcome tactical superiority, and how the ability to lose and immediately replace equipment created strategic advantages that battlefield skill alone couldn't counter. To understand the shock German tankers experienced facing endless Sherman production, one must first understand the world they came from, a world where tanks represented the pinnacle of industrial achievement and military investment. In 1939, when Germany invaded Poland, the Wehrmacht possessed approximately 3,000 tanks of all types. This number represented years of rearmament, massive industrial investment, and careful strategic planning. Each tank was a significant resource. German tank development followed a philosophy of qualitative superiority. The Panzer III and Panzer IV, Germany's main battle tanks when war began, incorporated sophisticated engineering, torsion bar suspension for superior cross-country mobility, intercom systems, allowing crew coordination, and carefully designed internal layouts maximizing crew efficiency. These weren't mass-produced weapons, but precision instruments requiring skilled labor, specialized components, and extended production timelines. A single Panther tank, introduced in 1943, required 13,000 man-hours to manufacture. Its Maybach engine alone took weeks to build, incorporating hundreds of precision-machined parts. The tank's complex overlapping road-wheel suspension system, while providing excellent ride quality, required specialized maintenance and couldn't be quickly repaired in field conditions. The optical rangefinder in the gunner's sight cost more than many nations spent on entire infantry squads' equipment. This engineering sophistication created formidable fighting machines. A Panther's 75mm gun could penetrate any Allied tank at combat ranges. Its frontal armor, 4 3/4 inches thick and sloped at 55 degrees, could defeat most Allied anti-tank weapons. Crew training emphasized these advantages. German tankers learned they commanded superior vehicles that could, under proper tactical employment, defeat multiple enemy tanks. But this qualitative approach carried inherent limitations. Germany's industrial base, even before Allied bombing campaigns intensified, couldn't match mass production demands. The Panther's complexity meant frequent mechanical breakdowns. Its sophisticated components required spare parts that became increasingly scarce as the war progressed. A damaged Panther often couldn't be repaired in forward areas, requiring evacuation to rear echelon facilities that might be hundreds of kilometers distant. German military doctrine accepted these limitations as necessary trade-offs. Superior individual tank performance would compensate for numerical inferiority. Well-trained crews in excellent vehicles could achieve favorable loss ratios, destroying more enemy tanks than they lost. This doctrine had worked brilliantly in France in 1940, where German armor overwhelmed numerically superior but poorly coordinated French and British forces. By 1944, however, this doctrine confronted a reality it hadn't anticipated. The enemy didn't just possess numerous tanks. The enemy could lose tanks at rates that would devastate any German formation and simply replace them faster than Germany could destroy them. The industrial system behind those replacements operated at scales that made German production look like artisanal craftsmanship. What German tankers faced wasn't just an enemy army, but an entirely different conception of industrial warfare, one where quantity itself became a form of quality, where the ability to rapidly replace losses transformed tactical defeats into strategic victories, and where the mathematics of attrition worked in reverse of every assumption upon which German doctrine rested. While German engineers labored over precision components and carefully managed production bottlenecks, American industry approached tank manufacturing with fundamentally different assumptions. The Sherman tank, officially designated medium tank M4, embodied a philosophy that German industrialists would have considered almost reckless. Design for mass production first, tactical performance second. The Sherman's development began in 1941 with explicit requirements that every component must be manufacturable by existing American industrial infrastructure. Unlike German tanks requiring specialized facilities, Shermans could be built by automobile factories, locomotive works, and even agricultural equipment manufacturers. The engine was a radial aircraft engine already in mass production. The transmission used components from existing commercial vehicle designs. The suspension employed simple vertical volute springs that any competent metalworking shop could manufacture. This design philosophy cascaded through every Sherman component. The turret casting, while complex, required techniques American foundries had mastered producing engine blocks for commercial vehicles. The 75mm gun, though less powerful than German tank guns, used ammunition interchangeable with existing anti-aircraft artillery, simplifying logistics. Even the tank's width, deliberately limited to 8 feet, 7 inches, ensured Shermans could travel on standard American railroad flat cars without special loading procedures. 11 different manufacturers across the United States produced Shermans. The Detroit Tank Arsenal, built specifically for tank production, occupied 40 acres under one roof and employed 15,000 workers. Fisher Body Division of General Motors converted automobile assembly lines to Sherman production. The Pressed Steel Car Company, which normally manufactured railroad equipment, produced Sherman hulls using the same heavy metalworking tools they'd previously employed on freight cars. The Lima Locomotive Works, American Locomotive Company, and Baldwin Locomotive Works all transitioned from building locomotives to manufacturing tanks. This distributed production system created redundancy that German planners couldn't match. When Allied bombing damaged German tank factories, production decreased, catastrophically. When one American Sherman plant experienced problems, 10 others continued operating. The system wasn't just large, it was robust, capable of absorbing disruptions that would have crippled more centralized production. Production numbers reflected this industrial approach. In 1942, American factories manufactured 10,706 medium tanks. In 1943, production reached 21,245. By 1944, even as American forces fought across Europe and the Pacific simultaneously, factories produced 17,981 Shermans. Total Sherman production from 1942 through 1945 reached 49,234 tanks. These numbers represented more than manufacturing capacity. They embodied a complete supply chain stretching from iron mines in Minnesota to steel mills in Pennsylvania to assembly plants across the industrial Midwest. The system consumed raw materials at rates that dwarfed Axis production. American steel production in 1944 alone exceeded 81 million tons, more than Germany and Japan combined. This steel fed not just tank factories but also shipyards producing Liberty ships at rates of 3 per day, aircraft factories building 50,000 planes annually, and artillery manufactories producing shells by the millions. The Sherman itself, while mechanically simpler than German tanks, incorporated sophisticated manufacturing techniques, welded hull construction, replacing riveted assembly, required fewer man-hours and created stronger joints. Cast turrets, rather than fabricated plate armor, reduced production time while maintaining protection. Standardized components meant that a damaged Sherman could often be repaired using parts from other destroyed tanks, something German tankers with their specialized components couldn't easily accomplish. What German intelligence services understood about American production capacity failed to adequately convey the psychological impact these numbers would create. Statistics in intelligence reports couldn't capture what it meant for a German tank commander to destroy 5 enemy tanks and face 10 more an hour later, to achieve tactical victories that meant nothing because the enemy treated tank losses as acceptable costs rather than catastrophic setbacks. The Sherman tank that German crews faced in 1944 stood 9 feet tall, weighed 33 tons fully loaded, and carried a crew of 5 men. Its welded hull construction incorporated frontal armor 2.5 inches thick, adequate against most German anti-tank guns at medium range, but vulnerable to the newer German weapons like the 88mm gun or the Panther's 75mm high-velocity cannon. The Sherman's own 75mm M3 gun could penetrate 3.5 inches of armor at 500 yards, sufficient against earlier German tanks but marginal against Panthers and wholly inadequate against Tiger tanks. These specifications meant the Sherman was, on paper, inferior to Germany's best tanks. A Panther could reliably destroy a Sherman at ranges where the Sherman couldn't penetrate the Panther's frontal armor. Tiger tanks, with their 88mm guns and 4-inch frontal armor, could eliminate Shermans at distances exceeding 1,000 meters. German tankers knew these advantages and exploited them ruthlessly. The tactical mathematics seemed straightforward. Superior German tanks would achieve favorable loss ratios, destroying more Shermans than they lost. What these calculations failed to account for was replacement rate. A German Panzer division's tank strength in 1944 typically numbered between 100 and 200 tanks. Losses of 20 tanks in a week represented catastrophic attrition, requiring operational term, withdrawal for reconstitution. The division might receive replacement tanks in 6 to 8 weeks, if production priorities and transportation networks permitted. Meanwhile, the unit ceased effective operations. American armored divisions faced different mathematics. A standard U.S. armored division contained approximately 250 medium tanks. Weekly losses of 20 tanks, while significant, didn't cripple operational capability because replacement tanks arrived continuously from rear area depots. The logistical system supporting American armored forces maintained replacement pools that could provide new tanks within days, sometimes hours, of loss reports reaching supply officers. This replacement system extended beyond merely providing tanks. Each Sherman arrived with a complete load of ammunition, fuel, and spare parts. The standardization that made Shermans easy to manufacture also simplified field maintenance. When a Sherman threw a track, the crew could often replace it using tools carried on the tank itself. When an engine failed, replacement engines arrived pre-assembled, allowing tank crews to swap entire power plants in several hours, rather than the days required for rebuilding complex German engines in field conditions. The Sherman's mechanical reliability further compounded German frustrations. The tank's Continental R975 radial engine, derived from aircraft designs, provided 350 horsepower and could operate for extended periods between major maintenance. German tankers reported that captured Shermans often ran longer between breakdowns than their own Panthers. The Sherman's simple suspension system rarely failed catastrophically. Its broad tracks distributed weight effectively, allowing operation in mud and snow that immobilized heavier German tanks. American crews received training that emphasized these practical advantages. Rather than focusing on achieving perfect gunnery under idealized conditions, American tank training stressed mechanical proficiency, crew coordination, and rapid response to battlefield conditions. Crews learned to perform field maintenance, conduct hasty repairs, and operate their tanks under extended field conditions. This training philosophy reflected the understanding that tanks would be used hard, damaged frequently, and needed crews capable of keeping them operational between depot-level maintenance periods. The crew layout inside a Sherman reflected this practical approach. The driver and assistant driver sat in the hull front with relatively comfortable seats and good visibility through periscopes. The turret housed the commander, gunner, and loader, with adequate space for sustained operations. German tankers who examined captured Shermans often noted the thoughtful ergonomics: ammunition storage that the loader could easily reach, controls positioned for intuitive operation, even small details like the provision of a hand-operated turret traverse for silent operation during ambushes. But these tactical and ergonomic details mattered less than the fundamental strategic reality the Sherman embodied. American industry had created a tank that was good enough for its tactical requirements while being excellent for its strategic purpose, being manufactured in quantities that rendered individual tank losses strategically irrelevant. The Sherman wasn't designed to win individual tank versus tank duels. It was designed to be produced in numbers that made losing those duels acceptable, because 5 more Shermans were rolling off assembly lines for every one destroyed. German intelligence officers analyzing captured Shermans understood the tank's specifications and tactical limitations. What they couldn't adequately convey to field commanders was the psychological impact of facing an enemy for whom destroyed tanks were merely consumed resources, no more strategically significant than expended artillery shells. Otto Carius, commanding a Tiger tank in Heavy Panzer Battalion 502, recorded his experiences facing American armor in his post-war memoir. His account, verified against unit records and contemporary after-action reports, reveals the dawning comprehension German tankers experienced confronting American production capacity. In July 1944, during fighting in Normandy, Carius's Tiger destroyed 7 Sherman tanks in a single engagement near the village of Mazy. His crew celebrated achieving a favorable loss ratio that should have represented tactical success. Yet Carius noted a disturbing pattern. The following morning, his unit faced 11 American tanks in the same sector. The day after, 15. Within a week, despite his unit destroying more than 20 American tanks, the number of Shermans his battalion encountered had increased rather than decreased. This pattern, incomprehensible under German operational assumptions, forced Carius to question whether destroying enemy tanks actually accomplished anything beyond consuming his own limited ammunition. The ammunition concern reflected broader logistical constraints German tankers faced. A Tiger carried 92 rounds of 88mm ammunition, sufficient for perhaps a week of heavy combat. Resupply required transportation from rear area depots, movement increasingly disrupted by Allied air interdiction. Panthers carried 82 rounds of 75mm ammunition. During sustained combat operations, German tank commanders learned to husband their ammunition carefully, sometimes declining to engage targets they could have destroyed, because preserving ammunition for critical situations took priority over achieving maximum kills. American tankers operated under different constraints. Sherman crews carried 90 rounds of 75mm ammunition as basic load, with additional ammunition readily available from supply vehicles accompanying armored units. The logistics system supporting American forces ensured continuous ammunition resupply. An American tank commander engaging targets didn't calculate whether each shot was worth the ammunition expenditure because more ammunition would arrive before existing stocks depleted. This logistical abundance extended to every aspect of American armored operations. When a Sherman's engine required replacement, the tank crew radioed for a new power plant, which typically arrived within 24 hours. When tracks wore out, replacement tracks materialized from supply dumps positioned near forward areas. Even minor components like periscopes, radios, or optical sights could be requisitioned and received within days. German tankers experienced opposite realities. Spare parts increasingly became improvised or cannibalized from destroyed vehicles. A Panther needing a new transmission might wait weeks for the component, assuming one existed in the supply system. Tank crews learned improvised maintenance techniques, jury-rigging repairs that kept vehicles operational but degraded performance. Some units maintained parts tanks, vehicles too damaged for combat but useful as spare parts sources for other tanks. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The psychological toll of these disparities accumulated gradually. German tankers understood they commanded superior individual weapons. The satisfaction of outranging and destroying enemy tanks remained real, but the strategic futility of these tactical victories became increasingly apparent. A company commander who destroyed 15 enemy tanks over a 2-week period couldn't celebrate when his intelligence officer reported enemy tank numbers in the sector had actually increased. Personal accounts from German tankers reveal recurring themes. The frustration of achieving what should have been decisive victories that accomplished nothing strategically. The exhaustion of continuous combat without adequate replacement periods because German formations couldn't withdraw for reconstitution while enemy forces maintained operational pressure. The growing realization that individual skill and superior equipment meant little when the enemy could afford losses that would have devastated German formations. Veterans interviewed decades later struggled to articulate the psychological impact. They had trained in a military tradition emphasizing tactical excellence and qualitative superiority. They believed skilled crews in excellent vehicles would prevail through superior performance. The reality they encountered invalidated these assumptions. The enemy they faced didn't need to be individually superior. Adequate performance, delivered in overwhelming quantities, achieved strategic effects that tactical excellence couldn't counter. The Battle of the Bulge in December 1944 crystallized the collision between German expectations and American industrial reality. Germany's last major offensive in the West began December 16th, with approximately 600 tanks and assault guns committed to the attack. German planners understood they faced numerical inferiority, but believed surprise, concentrated force, and winter weather neutralizing Allied air power would enable breakthrough to Antwerp, splitting Allied armies and forcing negotiated settlement. The offensive initially achieved tactical surprise. German armored spearheads drove deep into American lines, capturing fuel dumps and inflicting heavy casualties on unprepared American units. German tankers destroyed numerous American tanks in the first 72 hours. Kampfgruppe Paper, spearheading the advance, knocked out several dozen Shermans while sustaining minimal losses. The mathematics seemed to validate German doctrine, qualitative superiority producing favorable results. Then, American logistics activated. Within 48 hours of the offensive start, the U.S. First Army headquarters redirected Sherman replacements toward the Ardennes from depots across France. Tank transporters, previously moving empty back from forward areas, instead carried replacement Shermans forward. By December 20th, just 4 days into the offensive, American units that had lost tanks were receiving replacements faster than German intelligence believed possible. Major General Ernest Harman, commanding the 2nd Armored Division, recorded the effect in his after-action report. His division had lost 37 tanks in the first 3 days of combat. On December 21st, 45 replacement Shermans arrived from rear area depots. By December 23rd, his division operated at higher tank strength than when the battle began, despite sustained combat losses. This pattern repeated across multiple American armored units. German formations experienced opposite trajectories. The Panzer Division entered battle with approximately 60 tanks. After a week of fighting, they retained fewer than 30 operational vehicles. No replacements arrived. The division's commander requested tank reinforcements through normal channels and received notification that replacement Panthers might arrive in 4 to 6 weeks, assuming production priorities permitted allocation to Western Front units. Weather patterns delivered the final blow to German hopes. On December 23rd, skies cleared over Belgium, and Allied tactical air power devastated German logistics. Fighter bombers attacked fuel convoys, destroying the gasoline German tanks required for continued operations. Even undamaged German tanks began running out of fuel, immobilizing formations that had previously achieved breakthrough. Meanwhile, Allied air supremacy enabled continued resupply of American forces, including tank replacements that arrived despite German interdiction attempts. The psychological breaking point came differently for different German tankers, but common patterns emerged in post-war accounts. For some, it was seeing replacement American tanks arriving faster than German forces could destroy them. For others, it was the contrast between their own supply difficulties and the apparent abundance American forces enjoyed. For many, it was the simple mathematical realization that their tactical victories accomplished nothing when the enemy replaced losses faster than they inflicted them. Oberleutnant Hans von Luck, commanding a Panzer reconnaissance battalion during the Bulge, described the moment comprehension arrived. His unit had destroyed 11 American tanks on December 24th near Bastogne. The following morning, his scouts reported 19 American tanks operating in the same sector. Von Luck initially assumed they faced a different unit, but prisoner interrogations confirmed these were replacements for the destroyed tanks. In his post-war memoir, von Luck wrote that this moment crystallized his understanding that Germany faced not just military defeat, but industrial impossibility. The Ardennes offensive, Germany's last major attack, destroyed approximately 600 German tanks and assault guns that couldn't be replaced. American forces lost comparable numbers, but restored unit strength within weeks. By mid-January 1945, when German forces retreated to their start lines, the industrial mathematics had rendered final judgment. Tactical skill and qualitative superiority couldn't overcome industrial capacity that treated destroyed tanks as acceptable costs rather than irreplaceable losses. By January 1945, German panzer forces existed as shadows of their former strength. The Ardennes offensive had consumed Germany's strategic reserve without achieving any lasting gains. What remained were depleted formations operating tanks that couldn't be replaced, burning fuel that didn't exist, and facing an enemy whose material advantages had become absolute. The industrial disparity that German tankers had slowly comprehended throughout 1944 now manifested as overwhelming material reality. American armored divisions crossing the Rhine in March 1945 operated at near full strength. The 3rd Armored Division reported 232 medium tanks operational on March 15th. The 2nd Armored Division counted 218. The 4th Armored Division maintained 203 Shermans in operational status. These numbers represented not just current strength but sustainable strength, backed by replacement pools ensuring losses could be immediately compensated. German panzer divisions opposing these forces barely qualified as battalion strength formations. The Panzer Division, which had fielded 183 tanks in June 1944, counted fewer than 30 operational vehicles in March 1945. The 2nd Panzer Division reported 41 tanks present for duty. The 9th Panzer Division operated with 37 tanks. These weren't temporary reductions pending reconstitution. This was permanent degradation of combat power that no amount of tactical skill could overcome. The battles of 1945's final months demonstrated what modern warfare became when one side possessed industrial capacity and the other didn't. American armored spearheads advanced not because they fought brilliantly, but because they could absorb losses that paralyzed opponents. When a Sherman company lost 3 tanks capturing a village, 3 replacement tanks arrived the following day. When a German Panzer company lost 3 tanks, the company ceased effective operations. Otto Carius survived the war, surrendering to American forces in May 1945. In his post-war years operating a pharmacy in Germany, he reflected on the industrial disparity he'd witnessed. His memoir, published in 1992, acknowledged what many German veterans struggled to admit. They had fought superbly and lost anyway because war's outcome depended less on tactical excellence than industrial capacity. A skilled crew in an excellent tank meant nothing when facing 10 adequate crews in adequate tanks, with 20 more tanks en route. Ernst Bärkmann, the Panther commander who had watched endless Shermans advance through Bastogne's smoke, also survived. He returned to civilian life in Germany and rarely spoke about the war until late in life. In interviews conducted in the 1990s, Bärkmann described the psychological adjustment required to accept that everything he'd trained for, everything he'd believed about military excellence, had been rendered irrelevant by industrial mathematics he couldn't influence regardless of how well he fought. Hans von Luck, the reconnaissance commander whose realization came watching destroyed tanks replaced overnight, spent 5 years in Soviet captivity before returning to Germany in 1950. His post-war writings emphasized the lesson American production capacity taught. Modern warfare had fundamentally changed. Industrial capacity now mattered more than tactical doctrine. The ability to lose equipment and immediately replace it created strategic advantages that battlefield skill alone couldn't counter. The statistics from the war's final year illustrated the disparity's full scope. Between January and May 1945, American forces in Europe received 4,800 new Sherman tanks as replacements and reinforcements. German forces received fewer than 800 replacement tanks of all types during the same period. This 10-to-1 replacement ratio meant American forces could sustain offensive operations continuously, while German forces could only react defensively with degrading capability. The Sherman production that had so bewildered German tankers continued until the war's final weeks. The last Sherman manufactured for European theatre operations rolled off assembly lines in April 1945. Total production had reached 49,234 tanks in just under 4 years. This number represented more tanks than Germany had produced of all types during the entire war. American factories had built Shermans faster than German forces could destroy them, even had they destroyed every Sherman they encountered, which the combat loss rates demonstrated they hadn't. The industrial victory, American production, represented extended beyond mere numbers. The psychological impact on German forces had been cumulative and devastating. Tankers who began the war confident in their superior training and equipment ended it, understanding that individual excellence meant nothing when facing systematic industrial superiority. This realization, that they could fight perfectly and still lose because the enemy's factories outproduced their battlefield achievements, may have been more demoralizing than any tactical defeat. The Sherman production phenomenon that German tankers confronted represented more than manufacturing statistics. It embodied a fundamental transformation in warfare's nature that would define military conflict for the remainder of the 20th century and beyond. The ability to rapidly design, mass-produce, and continuously improve military equipment while simultaneously maintaining production of other war materials demonstrated industrial capacity's strategic primacy. American Sherman production existed within a larger industrial mobilization that German planners had catastrophically underestimated. While producing 49,000 tanks, American factories simultaneously built nearly 300,000 aircraft, hundreds of warships including aircraft carriers and battleships, millions of trucks and other vehicles, and literally billions of artillery shells and small arms rounds. This production occurred while maintaining civilian consumption levels that would have seemed fantastical to European populations enduring total war restrictions. The strategic implications revolutionized military planning. Traditional military doctrine had emphasized force preservation, achieving favorable loss ratios, and husbanding resources for decisive battles. American operational methods demonstrated that overwhelming industrial capacity enabled different approaches, accepting unfavorable tactical loss ratios because replacements arrived faster than losses accumulated, maintaining continuous offensive pressure without operational pauses for reconstitution, and treating complex mechanical weapons as consumable resources rather than precious capital investments. This shift influenced post-war military development across all nations. The Soviet Union, having witnessed American production capacity's strategic effects, prioritized mass production over individual weapon sophistication in its post-war tank development. The T-54 and T-55 tanks that dominated Soviet armored forces emphasized reliability, manufacturability, and ease of operation over technical sophistication. Soviet military doctrine explicitly incorporated the lesson American Sherman production taught: quantity possessed quality all its own, when production capacity could sustain losses. Western military forces drew opposite conclusions from the same evidence. NATO armies emphasized smaller professional forces, equipped with technically superior weapons, assuming quality advantages would compensate for numerical inferiority. This doctrine reflected confidence that Western industrial capacity could, if necessary, rapidly expand production to match or exceed any threat. The Shermans' legacy lived in this assumption that industrial mobilization capability mattered more than peacetime force size. The economic dimensions extended beyond military applications. American industry's ability to simultaneously produce military equipment at unprecedented scales while maintaining civilian prosperity demonstrated economic organizational capacity that became a Cold War strategic asset. The implicit threat that American factories could, if required, reproduce World War II's industrial mobilization influenced Soviet strategic calculations for decades. The knowledge that potential opponents possessed industrial capacity to replace losses faster than they could be inflicted shaped military planning across the globe. German veterans' post-war reflections on confronting American production reveal lasting psychological impacts. Many struggled to reconcile their battlefield experiences, where they often fought skillfully and achieved tactical successes, with the war's ultimate outcome. The realization that individual courage and tactical excellence had proved strategically insufficient challenged military culture's traditional values. Some veterans embraced this lesson, arguing that future wars required different approaches, emphasizing industrial capacity over martial valor. Others rejected it, maintaining that proper strategy and tactics could have overcome material disadvantages. The historical debate about Sherman effectiveness versus German tank superiority misses the strategic reality that German tankers themselves eventually grasped. Individual tank comparisons were strategically irrelevant when one side could field 5 tanks for every one the opponent produced. The Sherman succeeded not despite its tactical limitations, but because those limitations were acceptable within a strategic context, where destroyed tanks were immediately replaced and numerical superiority could be sustained indefinitely. Modern military analysts studying World War II increasingly emphasize logistics and industrial capacity over battlefield tactics. The Sherman production story illustrates why tactical excellence matters only within strategic contexts, where supply, replacement, and sustainability enable tactical capabilities to achieve operational objectives. German tankers possessed tactical excellence and superior equipment yet lost because the strategic foundations supporting their tactical operations collapsed under industrial pressure. They couldn't counter through battlefield performance. The legacy extends into contemporary military planning. Modern precision weapons, advanced sensors, and sophisticated platforms represent enormous individual capability investments. Yet the fundamental lesson American Sherman production taught remains relevant. The ability to replace losses and sustain operations matters as much as individual weapon capability. Military forces, optimized for initial combat effectiveness, Without sustainable production and replacement systems risk repeating Germany's experience, achieving tactical victories that accumulate into strategic defeat when material attrition exceeds replacement capacity. The story that began with Ernst Bärkmann watching Shermans advance through the smoke of their destroyed predecessors near Bastogne concludes with a profound historical irony. German tankers entered World War II confident that superior training, better equipment, and tactical excellence would ensure victory. They fought magnificently, achieved remarkable tactical successes, and destroyed enemy equipment at rates that should have guaranteed success. They lost anyway, not because they fought poorly, but because they faced an opponent for whom tactical losses were strategically acceptable costs. The 49,234 Sherman tanks American factories produced between 1942 and 1945 represented more than manufacturing achievement. They embodied a different conception of modern warfare, one where industrial capacity determined strategic outcomes more decisively than battlefield courage or tactical skill. Each Sherman rolling off assembly lines represented not just a weapon, but a vote of industrial confidence that losses could be sustained, replaced, and overcome through systematic production capacity. German tankers gradually comprehended this reality through accumulated battlefield experiences. The first destroyed Sherman replaced immediately suggested efficient logistics. The 10th suggested abundant reserves. The 100th suggested something beyond their reference framework, an opponent for whom tank losses were merely consumed resources, no more strategically significant than expended ammunition. This realization, that they fought not just an army but an industrial system operating at scales that rendered their tactical victories strategically meaningless, proved more demoralizing than any battlefield defeat. The human cost of this industrial disparity manifested in individual stories. Ernst Bärkmann survived the war but carried memories of watching friends die, achieving tactical victories that accomplished nothing because destroyed enemy tanks were replaced before the smoke cleared. Otto Carius lived into the 21st century, dying in 2015, long enough to see his wartime memoirs become historical documents studied for insights into the psychological experience of technological and industrial obsolescence. Hans von Luck's post-war writings repeatedly returned to the theme of excellent soldiers rendered strategically irrelevant by industrial forces beyond their control or influence. These men and thousands like them learned warfare's hardest lesson. Individual excellence matters only within strategic contexts that enable tactical achievements to accumulate into operational success. Without sustainable logistics, adequate replacements, and industrial capacity to replace losses, tactical victories become Pyrrhic achievements that exhaust forces without achieving strategic objectives. They fought perfectly and lost anyway because the enemy's factories fought better than their tanks. The broader historical significance extends beyond World War II's specific circumstances. The Sherman production phenomenon demonstrated that modern industrial warfare had fundamentally changed conflict's nature. Traditional military virtues of courage, skill, and tactical excellence remained necessary, but were no longer sufficient for strategic success. Industrial capacity, logistical sustainability, and the ability to absorb and replace losses had become equally crucial determinants of victory or defeat. This transformation in warfare's nature influenced every subsequent major conflict. The Korean War, Vietnam War, and subsequent military operations all reflected lessons American Sherman production taught about industrial capacity's strategic primacy. Military forces optimized for initial combat effectiveness without sustainable production learned expensive lessons about attrition's cumulative effects. Nations that could replace losses and sustain operations prevailed over opponents who fought skillfully but couldn't maintain material strength. The story of German tankers confronting American Sherman production offers enduring insights into conflict's nature. When industrial capacity creates asymmetric advantages, it reveals how technological sophistication and tactical excellence become strategically insufficient when facing opponents who treat equipment losses as acceptable costs rather than catastrophic setbacks. It demonstrates how individual courage and skill, while admirable and necessary, cannot overcome systematic industrial disadvantages that render tactical achievements strategically meaningless. Most profoundly, it illustrates modern warfare's central paradox. The side that can afford to lose often wins. German tankers destroyed more Shermans than they lost Panthers and Tigers. They achieved favorable tactical loss ratios. They fought skillfully with excellent equipment. None of it mattered strategically because American factories replaced destroyed Shermans faster than German forces could destroy them. The mathematics of industrial warfare had rendered traditional military calculations obsolete, a lesson purchased through the bitter experience of soldiers who fought brilliantly and discovered that excellence alone couldn't overcome industrial mathematics. The Sherman tanks that so bewildered German tankers now rest in museums across the world, preserved as artifacts of industrial triumph. They represent not just American manufacturing prowess, but a fundamental shift in how wars are won. The approximately 5,000 surviving Shermans in various museums, private collections, and memorial sites serve as tangible reminders that modern conflicts' outcomes depend as much on factory floors as battlefields, that industrial capacity can prove more decisive than tactical genius, and that the ability to lose and replace equipment creates strategic advantages that battlefield skill alone cannot counter. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.